In this video, I'm going to take you through the Lami's theorem. We've already gone through the sine rule, the cosine rule, and the parallelogram law in our previous videos. Now, Lami's theorem is another theorem we use to simplify forces acting at a point. So, let's see how Lami's theorem works. Assuming you have forces acting at a point this way, and the forces moving outward this way. There will be an angle between these two as alpha, beta, then gamma. You have A, B, then C. What Lami is saying is that when you take any of these forces pointing away, so let's say if you take C, then C over the sine of the opposite. So C over sine of 180 minus the opposite angle. So sine of 180 minus A should be equal to B over what? Sine of 180 minus this angle. 180 of what? Y should be equal to what? A over sine of 180 minus B. So this is Lami's theorem. You only need to get the angles between the forces. Then when you take one force over the sine of the angle minus 180, then you are supposed to equate for all the three. Now let me give you a question so you understand the Lami's theorem. So we have a ceiling where two strings are hanging a box. The box weighs 30 kilograms. This is our point A, our point B. Then assume horizontal. The angle this is making is assume horizontal is a 45 degrees. This is 30 degrees. We have to use Lami's theorem to find the tension in this rope T1, T2. How do we do that? Our goal is to express this in this form, where we get the angles between any two of them. Then we can go ahead to apply the Lami's theorem. So first of all, let's convert this one to force because you are looking for tension, which is a force. So 30 times gravity, acceleration of gravity, which is 10, so it's going to give us 300 newtons. So if you are giving acceleration due to gravity to be 9.8, that is also going to give us 297. But in this case, you are using 10. So let's see. This diagram here, you can clearly see that. Let me redraw it. So when I draw the force diagram, I'll have this, I'll have this, I'll have this. So this is my T1, this is my T2. Then this is the weight, 300 Newton. Now let's see. The angle T1 is making here is what? 45. This place is a vertical because it's weight. It's making an angle of 90 with this, 90 with this. To find the total angle here, I'll add 90 to this and I'm getting 135. So the total angle between T1 and 300 is 135 degrees. Now, this side is 30. Here is 90. So this place will give me 120 degrees. Then finally you add this, you are going to get 135 plus 200 plus 120. That is 255. Then you subtract it from 250 to get the remaining angle here, 105. Now we apply Lami's theorem to get our T1 and T2. So if I take the known one, it will help me to get the unknown. And I'll take it 2. So 300 over sine of 105, that is the opposite angle. So sorry, 300 over sine of 180 minus 105 should be equal to, let's say, T1 over what? Sine of 180 minus 120. And I can use that to find T1. So let's see. I'll get 300 over sine 75 is equal to T1 over sine 60. So my T1 is simply equal to sine 60 times 300 all on sine 75. So what am I getting? Sine 60 times 300 all over sine 75. So this is equal to, my T1 tension 1 is equal to 268.97 Newton. Now let me go to T2. I can use this same thing for T2. So T2 over 180 minus 135. T2 over 180 minus 135. Sine of this whole angle should be equal to 300 over sine of 180 minus 105. So my T2 over what? Here is going to give me 45. Sine 45 should be equal to 300 over sine 75. T2 is simply equal to 300 times sine 45 all over sine 75. So T2 now comes, so 300 times sine 45 over sine 75. So T2 is equal to 219.62 Newton. Thank you for joining me in this video. Please subscribe, like and share. Hope seeing you in the subsequent classes.